Hi guys, so we're first going to look at the final review part 3. So right here we're asked about perpendicular and parallel lines. What is the slope of a line when we have parallel to the line joining at 2, 4 and 5, 12? And this one is what is the slope of the line that's perpendicular to the line joining at 2, 4 and 5, 12. So it's the same type of slope, we're just looking to see what happens when we look for a parallel line and a perpendicular line. So right here, first thing that we want to do is to identify what the slope of 2, 4 and 5, 12 is. So right here, I'll just write it in the middle since this is part of both our questions. So whenever we're looking for a slope, we use the formula n equaling to y2 minus y1 dividing by x2 minus x1. And we have the ordered pairs 2, 4 and 5, 12. So if I'm going to label this, then I need to choose one of them to be my x1 and y1 value. So I'll choose 2 and 4 to be my x1 and y1, which means that 5 and 12 are going to be my x2 and y2. And then once I do that, I'm just going to plug it into my formula here. So y2 was 12, I'm subtracting that with y1, which is 4. x2 is positive 5. I'm subtracting it with positive 2. So I get here 12 minus 4 over 5 minus 2. 12 minus 4 equals to 8. 5 minus 2 equals to 3. And that would be my slope right here. Now once I get my slope down, then I can answer these two questions. So let's look at this one first. We're looking at parallel lines. If we already know the slope, we know that parallel lines have the same slope all the time. So parallel lines have the same slope. So if we originated with m equaling to 8 over 3 as our slope, that would be the end of my answer because it's the same slope. Perpendicular lines are a little bit different. So let's write here perpendicular lines. In this case, I need to change the sign. Change the sign. So if you have a positive slope of 8 over 3, it needs to be changed to being negative. If it was a negative slope, you would have to change it to being positive. But in this case, we had a positive one. So we changed it to negative. And then after we do that, we also need to flip our fraction. So if we have now negative 8 over 3, we need to flip it so that it's negative 3 over 8 instead. And that would be your final slope. So right here, n would equal to negative 3 over 8. That would be the perpendicular slope to our original slope, positive 8 over 3. Okay? Alright, let me clear this. And then let's look at solving equations. There's 3 different ways that we could solve an equation here. First one is solving for w when you have p equaling to 2w plus 2l. So what they're asking us to do here is to isolate w so that w is completely by itself. If we have here p equaling to 2w plus 2l, I need to start off by subtracting 2l on both sides. The p minus 2l can't combine together, so I have to leave it as p minus 2l equaling to 2w. And then, since 2 is multiplying with w, I need to divide 2 on both sides to get rid of that 2. So when I do that, I'm left with p minus 2L, oops, not 2W, 2L over 2 equals 2W. That would be your final answer because W is completely isolated. The next question is asking us to solve when you have negative 3x plus y equaling to negative 3 and 2x plus minus 2y equaling to 10. So for this one, I want to isolate either the x value or the y value. It seems like it would be easier if I can isolate this y value here. So I'm going to use this equation first. We have negative 3x plus y equaling to negative 3. To solve for this, I need to add 3x to both sides. When I do that, I'm left with y equaling to 3x minus 3. So by doing that, it completely isolated the y. After I do that, the next step is to plug in this entire expression into 5x minus 2y equaling to 10. So I'm going to plug in all of this into our y value here. So we get 5x minus 2 times 3x minus 3 equaling to 10. And so I'm going to distribute the 2 to both the 3x and to the negative 3. When I do that, I get 5x minus 6x. Negative 2 times negative 3 gives me positive 6 equaling to 10. And then I can combine the like terms, 5x minus 6x, which would be negative 1x, plus 6 equaling to 10. And then after I do that, I'm just solving for x. So I can subtract 6 on both sides. That would give me negative 1x equaling to 4. And then I need to divide negative 1 on both sides. When I do that, I'm left with x equaling to negative 4. So once I have that value, the second value I need to find is the y one. So to find y value, let me actually move this all to the side. Let's see if it'll let me move it. Oops, didn't get everything. Let's see, move it to the side here. Okay. The next one that I need to find is the y value. So I'm going to pick one of these two. I'll just pick the equation 5x minus 2y equaling to 10. And I'm plugging in the negative 4 into the equation so that I can find out what my y value is. So if I plug in x equaling to negative 4, I get 5 times negative 4 minus 2y equaling to 10. That would equal to negative 20 minus 2y equaling to 10. And then I'm just solving for y. So I would add 20 to both sides. When I add 20 to both sides, I get negative 2y equaling to 30. And then I need to just divide negative 2 to both sides so that I get y equaling to negative 15 as my answer. And so if you are asked to put in an ordered pair, remember that it's x comma y. So x goes first, negative 4 goes first, and then y would go last. So your negative 15 would go to the right. Okay. Alright. Last one is to solve for 0 equaling to negative 15 plus 5 times the square root of 5y plus 4. So before I do anything, I want to make sure that my square root is completely isolated. So to do that, I need to add 15 to both sides. When I add 15 to both sides, I get 15 equaling to 5 square root of 5a plus 4. From there, I'm going to divide by 5 on both sides. And so I get 3 equaling to square root of 5a plus 4. And then to get rid of this square root, I just need a square on both sides. When I square on both sides, I'm left with 9 equaling to 5a plus 4. And then I just solve for a. So subtract 4 on both sides. When I do that, I get 5 equals to 5a. Then I divide 5 on both sides to get my answer, which is 1 equaling to a. And so from there, I just want to see if this is the correct answer. So I need to check it. So to check it, let me put it here. Check. And then I'll just put like a line here so that it shows this is completely different from our answer. So to check this, we have 0 equaling to negative 15 plus, I don't have enough space there actually. Let me go a little bit lower. 0 equaling to negative 15 plus 5 square root of 5, and I'm going to plug in the 1 into there. 1 plus 4. So from here, I get negative 15, 5, that turns into 5 plus 4. And so we get 0 equals to negative 15 plus 5 square root of 9. Square root of 9 is just 3, so that would be times 3 minus 15. And then we have here negative 15 plus positive 15. So we get 0 is equal to 0. So because of the fact that this is a true statement, that means that 1 equaling to a is our final answer. Okay, so here we have 2 multiplying with the absolute value of 2x plus 6 equaling to 12. So again, I want to isolate the absolute value. Now to do that, I need to complete the opposite operation, which is to divide 2 on both sides. So right here I get absolute value 2x plus 6 equaling to positive 6. Once I do that, I need to create 2 equations. So we get here 2x plus 6 equaling to 6, which is exactly the same. The only difference is that the absolute value is gone. And for this one, it's exactly the same, except I'm going to multiply my answer with negative 1. So when I do this, I just solve for x. So I'm going to subtract 6 on both sides. I get 2x equaling to 0. This can be divided by 2, and I get as my answer x equaling to 0. So that'll be my first answer. This other one, we have 2x plus 6 equaling to negative 6. I'm going to subtract by 6 on both sides so that I get 2x equaling to negative 12. I'm going to divide 2 on both sides so that I get as my answer x equaling to negative 6. And that would be my final response. So hopefully this helped. Good luck.